Hi gentlemen, welcome to a new chapter, Excretion in Humans. Before we begin, let us review the different human systems that we have gone through so far in biology. So in chapter 5, we started off in digestive system. Why is this the first system that we introduce? It's because it helps us to understand the raw building blocks needed in various chemical reactions in our body, and these raw building blocks are namely glucose, amino acid, and glycerol plus fatty acid, which represents the three basic biological molecules that our body requires. Then we move on to circulatory system to understand the movement of substances in our bodies. How are they transported? How does the heart pumps these materials through our bodies and where they are being transported to? Then we went on to respiratory system. The main objective of respiratory system is to release energy by breaking down glucose. And I hope that you can see the synergy across the various body systems that we have learned so far and how they come together to work with each other. Today, we will start off with excretion, and you will learn more about the excretory system, which works very closely with other body systems that we have learned so far. So in the first video, we will learn about the importance of excretion and understand why is it necessary to remove waste products from our body. And we'll be looking at 4 different excretory products, namely carbon dioxide, urea, mineral salts, and water. How they are excretory products and how they are removed from our bodies. You may wonder why water, an important component that our body needs, can also become an excretory product, and we'll find out more in this video. Let's begin with the definition. Why is excretion so important? In our body, many different chemical reactions happen in our cells. And these chemical reactions are known as metabolic activity. Some example of metabolic activity includes cell division, respiration, growth, repair, and many others. With every chemical reaction gives rise to new products produced. These products could be either helpful or harmful. As such, in order to make sure that our bodies do not retain harmful substances in excess, this is where the excretory system comes into place to remove the harmful products that are produced during metabolic activity. So we refer to the waste product as metabolic waste or excretory products. And these products become very harmful when they exceed normal level, posing as a danger to our health. So in conclusion, the definition of excretion is to remove metabolic waste product or substance, okay, and or substance that are excess in our body. All right. So let's look into the different metabolic waste product. But before that, I want to bring your attention to this particular confusion that many of you typically have. A common misconception is over here. So when we talk about feces, some may mistook feces as an excretory product, but it is not. Undigested product is not the same as excretory product. Why are feces formed at the end of our digestive system? It's because the food are left undigested. It's a physical reaction actually on the formation of undigested waste products. Also, feces is not formed as a result of a metabolic reaction. No chemical reaction take place to result in the formation of feces. As such, egestion of feces is just the physical removal of undigested products, while excretion focuses on the removal of metabolic waste product. Alright, so I hope you can tell the difference between egestion and excretion at this point of time. Let's dive into each individual metabolic waste product right now. So by the end of this lesson, you must be able to answer 2 questions. How is it produced? And why must it be removed? So let's begin with carbon dioxide. We know that carbon dioxide is produced during aerobic respiration, where glucose is being broken down in the presence of oxygen to release 2 products, carbon dioxide and water. When carbon dioxide is in excess, it results in a condition called hypercarbia, and people who suffer from this condition typically have difficulty breathing. They experience an increase in their heart rate and often look very confused and suffers from a very bad headache. Looking at all these symptoms, I would like you to make the connection. Why did a high level of carbon dioxide in an individual leads to these symptoms? I'll pause over here for a little bit for you to generate some ideas in your head. I'd like you to pen it down before I reveal the answer. What do we know about carbon dioxide? It is able to bind to red blood cells. As a result, it will lead to a decrease in transport of O2 efficiently in the morning, in the body. So as a result, it will lead to high heart rate as well as rapid breathing in order to remove CO2 and take in oxygen that the body needs. Second, urea. This word should ring a bell in your head. And how is urea formed? In chapter 5, digestive system, we learned that when there's excess amino acid present in the liver after absorption, these excess amino acid will undergo deamination. Recall, deamination refers to the removal of amino group of the amino acid, which will then turn into urea. So it is a very toxic and harmful product, and if a high level of urea is found in our body, it results in uremia, which often leads to fatigue, nausea, and if in worst case scenario, seizures as well. Thirdly, water. You may be puzzled to think, how is water an excretory product? First thing first, we need to identify how is water produced in our body. And I bring your attention back to aerobic respiration, where the two products are CO2 and water. Too much of anything is not good for you, alright? And this concept also applies to your body. Too much of something too good is also quite harmful in the long run. And I would like you to pause here to think, why must excess water? I emphasize on the word excess. When water becomes excess, it becomes a metabolic waste product. So I'd like you to think, what happens to your body when there's excessive water found in your blood plasma? So when there's increase in water potential in blood plasma, the water potential in blood plasma will be greater than the water potential in your cells. Then what would happen? Right, let me put it down in words. So the water potential in blood will exceed the water potential in cells. So by the nature of osmosis, water enters cells, and this causes the cells to swell and burst, posing as a danger to our body. Hence, excess water in our body must be removed. Lastly, mineral salts and ions. For example, calcium, sodium, potassium, and magnesium. These are mineral salts that our body needs as well. But the lack of it poses as danger, and also the excess amount of it will also threaten our body as well. So over here, I also like to emphasize, we need mineral salts, but when it's excess in our blood, it can be harmful. Similarly, I'd like you to pause and think, what will happen to the body when there's an excess of mineral salts in cells? When there is excess mineral salts, it results in a decrease in water potential in your blood plasma. So what will happen in this scenario instead? The water potential in your cells becomes greater than the water potential of your blood. So similarly, water will pass out from the tissue cells into the blood by osmosis. As a result, what would happen to your cells? So your cells will eventually shrink and becomes dehydrated. So when it's in excess, it becomes very harmful. Lastly, we would like to learn about the different body organs that are involved in excreting each of the metabolic waste product that we have discussed. First thing, carbon dioxide. It is being removed by your lungs in the form of gas when you exhale it during breathing. For excess mineral salts and urea, two different organs are responsible for excreting it. So for the kidneys, you will find the excess mineral salts and urea in your urine, which will be expelled. When we sweat, I'm not sure if you accidentally tasted your sweat before, especially if you are having a very tough exercise session, and the sweat drips into roll down your face and enters your mouth. You realize that it's rather salty. It's because the excess mineral salts and urea are being expelled from your body through your skin in the form of sweat. As for water, there are three different ways of removing them. First, through your urine. Second, through your sweat. And thirdly, through your lungs as well, as water vapor is found in high proportion when you exhale during breathing. That's it for 8.1. I'll leave you with the last question. And I think this is very relevant to all of us. Well, I mean, we all want to smell good and feel clean, especially after sweating excessively. So I'm not sure if you guys use antiperspirant, which is different from deodorant. Alright, antiperspirant, alright, reduces sweating. So now that you understand about excretion, would you use antiperspirant to prevent body odor when exercising? Why or why not? I'll leave you to pen down your thoughts about this, and then we'll bring the discussion back into the classroom.